In this video, we're going to look at the chain rule for derivatives. So thus far, we've looked at the power rule, we've looked at the sum and difference rule, and we've looked at the product and quotient rules. But now we're going to look at the chain rule and see what that is and how that relates with our functions. So if we say that y equals f of u, all right, now wait a minute, we normally say f of x, but let's see what u is all about. And u is equal to g of x. Then we have the function or the equation y equals f of g of x. So this may look familiar, hopefully it looks familiar. This is a composite function. So y is a composite function. G of x is its own function, which we'll call u, and that's put into f of x, right? So when we find our derivatives, we're finding dy of dx. Now this is a notation we don't use a lot, that I don't use a lot, but this is saying the derivative of y with respect to x. So normally we just find the derivative by using one of the various rules that we talked about at the beginning of the video, and we just get our derivative of y with respect to x. But now to get to x, we have to get to g of x. But to get to g of x, we have to go through u, or we have to go through our function f of x. So we have to start with dy of du. So we're finding the derivative of y with respect to u. So that's kind of our first layer. But then we need to also find the derivative u with respect to x. So we're kind of digging down to get to our x. And we could also write this as f prime of g of x times g prime of x. So that's kind of what this dy over du times du over dx is saying. So let's look at an example. This might help, but essentially what's happening is you've got an inner function, the g of x. That's what we call our inner function, or what I call our inner function. And then we have our outer function, and our outer function is going to be our f of x. So this is kind of another two-part derivative, but you'll kind of see here in a minute about what our inner and outer functions are. So let's look at an example. So let's say we've got f of x equaling x squared plus 1 all cubed. So we first want to find our inner function. Our inner function is x squared plus 1, and our outer function is going to be the x squared plus 1 cubed. So it's kind of the whole thing. So our first piece for finding our derivative is going to be 3 times x squared plus 1 all squared. Now that's just taking the derivative of the outer function. We move using the power rule, we move the 3 to the exponent 3 to become a coefficient. We subtract our 1 from our coefficient. Everything else stays the same. So that's our outer function. Now we want to find the derivative of our inner function, and that's going to be our x squared plus 1. So the derivative of that we know is 2x. So now from here all we do is we do some multiplying and simplifying. So 6x equals x squared plus 1 all squared. Now we could of course expand that out, but that's not going to make it any more simpler or any more easier to look at, so we'll just leave it like this. So let's look at another example. F of x equals sine of 2x. Alright, now I always say that sine and this 2x or sine of x or sine of whatever is all one chunk, right? We can't break that apart because it's kind of a composite function, just like we have here. So we're going to use the chain rule because we don't know what that 2x is. That can change. So we have to take that into consideration. So let's start by looking at our derivative. We're going to look at our outer function. So we now know that the derivative of sine 2x is going to be cosine of 2x, and then our inner function is going to be this 2x. So we find the derivative of that, which we know is going to be 2. So the derivative of sine 2x is going to be 2 cosine 2x. Just again, multiplying and simplifying. Alright, we got one more example we're going to look at. F of x equals the square root of cosine x. Alright, well, having that square root, having that radical sign, and there just kind of makes things a little bit more complicated. So I like to try and make those into exponents. So we're going to say cosine x to the 1/2 power. All right, now it's going to be a little bit more apparent that we have a composite function. We're going to need to use the chain. So as we use the chain rule, we're going to start by looking at the outer function. So we're going to take 1/2 cosine x and to the negative 1/2 power, because remember we subtract 1. And then we're going to take the inner function, which is cosine x. The derivative of cosine x is negative sine x. Now when we multiply and simplify, let's move this over here and give ourselves a little bit more space. We have negative sine x over 2 times the square root of cosine x. And that's just moving our cosine x into the denominator because of the negative exponent, multiplying by 1/2, and that's what we get. So I hope this helps. The chain rule, this is going to be the last of our derivative rules to help us find derivatives, and we'll talk to you in the next video.